Hi, my name's Nathan. I'm one of the founders here at Deschutes Tech Guild. And so anyway, we like to get everybody together and like have some community and have a meetup where everybody can network and have a great time. So this is what we do. We host events every second Tuesday of every month. It's going to be here at BenTech unless we state otherwise. So we have this and we just have fun with it. So I want to talk about our speakers real quick. One of our speakers is Sneak. Sneak, if y'all ever seen Sneak. Speakers, sponsors. Sponsors.
Talk about your sneakers.
They're pretty slick, actually. So Sneak is a security vulnerability, and they're basically an all-in-one security platform. If y'all ever met Randall, who will come in here, pop in here every once in a while, he's a really great guy. He'll tell you all about it. They've been a really great sponsor over the last 2 years. They basically help them and then Craft CMS basically donate a whole bunch of money for food. So if you could go check it out, especially if you're doing a lot of open source work and doing dependency scanning on your node modules, stuff like that, it's really a great resource. I have it on a bunch of my repositories as well. And so the next one is Craft CMS. Craft CMS is it's like a headless CMS. They have an all-in-one platform for hosting your CMS. I think they target it towards WordPress and PHP platforms. But they have a really great product, and they've been generous for a long time. You'll see Brad will be in here every once in a while. I don't think he's here tonight, but also a really awesome product. And our third sponsor is BenTech. They generously give us this space where we can host our events here for free. And basically, they have some really awesome options. It's a co-working space. So here is the lobby. Inside here is where you have your dedicated and float desks as well. They're really great. Jason is in here. He's really awesome. Basically, when you're working remote, one of the really big values of being in a co-working space is that you're mixing with a bunch of different people. And so the issue is with working remote is that you're just by yourself unless you intentionally go out and network. You don't really get that when you're working remote versus in person with a bunch of people. So that's one of the big benefits of coming here. There's coffee, you can have mail service, a whole bunch of great stuff, and I've been working out here for a month or so now. It's really great. There's a whole bunch of dogs that are awesome. Anyway, it's a blast. All right, and so afterwards we have Cloud Beers. So Cloud Beers has long history, has been longer than Deschutes Tech Guild and BenJS. Basically, it started, if I remember correctly, a group of guys that were meeting together after conferences, and they decided let's do this more regularly. And so anyway, basically we partnered up with Cloud Beers, and basically we've been partnering up with them and with Matt Small over here. He's one of our other organizers. Wave your hand, Matt. So anyway, basically after this, we were going to be heading down to River Pig to grab a drink. Me and some of the other guys. I haven't seen Gable yet, but sometimes we'll play board games down there. We did that last week. Another great way to keep networking after here when we kick y'all out. And okay, and then we have some networking stuff. So just as a show of hands, who is hiring right now? Okay. And who is hiring junior positions? Okay. And who is looking for work right now? Okay. So make sure you hound the people that are hiring. Just swamp them. Be really aggressive. No, just a joke. All right. Okay. The other thing too is that we really want to keep building an online community where basically people can come and join on our Discord. So we have, I think we have 150 members on there now. So it's a great way to connect outside, and Craig right here and then Aiden are on there all the time and just actively adding to the conversation. It's great. It's also a great way as a developer to ask questions and spread you're kind of it's a little bit like a mind map, right? So basically, when you're throwing something out there on one of the channels, basically everybody sees it, and then there's more chance of somebody knowing the issue that you're dealing with. and then they can help you out. And it's also another great way to keep networking too. So whenever you can, like, join our Discord. We'd love to have you, and yeah.
Isn't it the same QR code there and there, I feel like?
Yeah, it is.
Maybe not. Oh, is there a secret Discord I don't know about?
No, definitely not. We got the one. Okay, so this one's a little bit out of date, but basically, yeah, we have the next meetup is on June 10th, and we're gonna have an awesome talk. And okay, and then I'm gonna introduce Brad. Brad is one of our Deschutes Tech Guild members. And so him and his wife have been developing an app, and he wants to talk about it real quick. Here you go, Brad.
Right.
All right. Here we go, Brad.
So me and my wife are making an app. We live here in Bend. She's the designer, I'm the developer. And it's an app to help you meet people in the community to do activities with. We work remote, we've moved a lot, we have kids. It's just hard to meet people. And so we kind of wanted to solve our own problem by building an app that will help you meet people in the community. And what better way to meet people than to do an activity with them so you don't have to talk to them in case you don't vibe. So we're still in like beta. We're just released in Bend. There's not a lot going on in there. We've got like maybe 50 users, and we're trying to just continue to get users and pilot the app here in Bend and get feedback on it. And we've created a group code for this tech guild, so that if you use the app and you use the group code when you're creating invites to go do activities with people, you can target just people in this group, so we can kind of help foster this group, getting to know each other better. And I'm going to be doing a deeper dive on the tech and the code sometime in fall here. So it's just for iOS right now, so sorry, Android people. And, yeah, that's it.
All right. Thanks, Brad. That's great.
Thanks to the QR code.
Yeah. All right. Well, great. Okay. All right, Aiden, are you ready?
Oh, it's me first.
Yeah, it's you first.
Oh.
You volunteered to be guinea
Oh, wait, so that wasn't
If everybody wants to go grab tacos real quick, grab some drinks, you can do that real quick, and then we're going to get started here in just a second.
Do we have like special laptop trays?
Yeah, it's right
This
here.
is cool.
It's really,
Also,
it's
aren't they
really
supposed to be
bougie.
techno?
It's really bougie. That's incredible.
It's got
Nice.
Okay.
Let me see if I can do this.
You're live.
Yeah, I know. Thank you.
Live. That's so cool.
Yeah, this is nice. So I'll try
Nuts! All right. Oh, and also, Aiden, we need to keep you like right around here, and you
Oh,
need to face this way because of the camera.
All right. Sweet.
All right.
Okay. Hey everyone, my name is Aiden. Last month, I think it was last month, time flies by when you have a 3-year-old. I gave a talk last time on Nuxt and Nitro.js and background processing and WebSockets, live events to keep users up to date on what's going on. And so I wanted to do another talk on the front end stuff because I feel like we don't get a lot of that here, but a lot of us are web developers, so I wanted to continue that. So today I'm going to be talking about data fetching with Nuxt. Nuxt is a server-side rendered framework, and so if you work with Next.js, Angular, I'm sorry if you do, and Nuxt, we're going to be talking about best practices for data fetching on the server and the client in 5 minutes or less, kind of like a Fireship IO video, so let's dive into it. Before we get too far into this, I need to do a brief summary of the universe with client-sided rendering. If you're a web developer or you've talked to anyone about the web, you're pretty familiar with this, right? The server has some HTML, JavaScript, some CSS, a user requests it, they get it, then the browser gets this kind of HTML, gets this markup, you get that div with an ID of app, your application has the JavaScript hydrate, and then you get all that powerful stuff like interactivity, data fetching, all this really cool stuff that we can build with React, Vue, Alpine, whatever you use. But if we take a look at a component, right, so this is a basic Vue component. Right here we have a script block with the setup using a composition API, and here we're doing some data fetching, and we have a suspense guard around our markup. And the problem with this is that it takes time, right? So with our ADHD-riddled youth, they want things now, And so if I have to wait for the JavaScript to render, then for the data to be fetched, and then for all the markup to show, that takes too much time and the user's going to lose interest. So basically what we do now is server-side rendering. And this is very cool because the user can request my page. We can do some dedicated processing on the server, request data, build the page, send it back to them, and that first contentful paint is very quick, right? And so this is great for like blogs, articles, where maybe we just need to fetch some markdown, turn it into markup, and then render the page for the user and ship it off to them. So it's very fast. But little side note, if you're a Vue developer, Nuxt, the framework I'm going to be talking about, automatically wraps your pages in suspense blocks for you to handle asynchronous logic. So in my examples, I'm going to skip over that, but it gets handled for you by the framework. So what we need to dive into real quick before we can talk about data fetching with Nuxt is OFetch. And so the UnJS team created a new HTTP client, kind of like Axios, if you guys are familiar. And it's meant to run on Node, browsers, workers. Everything within the Nuxt or UnJS environment is meant to live on the edge. So all of the tooling there is meant to work anywhere that you want to deploy it in some very modern deployment environments. And so this is the underlying HTTP utility. And so what that moves us into first is $fetch. And the reason it's called $fetch is Node has its own fetch utility, right? So we don't want a conflict of namespaces. So $fetch is basically like your regular fetch utility. It's used after the page hydrates, right? So with Vue, with React, we're going to get a page, the JavaScript is going to run, we're going to get the page that renders, and then we can start to use $fetch. The big caveat with this is that there is a data duplication on the server, right? So when we talk about server processing, $fetch, when the server runs, it's going to make a fetch request using $fetch, and then on the client, it's going to run again. So if you use this on the server, it's going to duplicate your requests. And it's really just an instance of the OFetch library, and so we can use it on the client, just like you would fetch for interactivity, right? They click a button, they move a page, they change the layout, something along those lines. But if you're pretty familiar with Vue, on mounted, we go ahead and fetch data because after mounting, we know that the hydration has finished here. And so what we get also is we can move $fetch into the server. If you're familiar with Nuxt or any kind of server-side framework, you also have a server in the backend, and the server for Nuxt is Nitro. And so here we would use $fetch in the backend because there's no hydration, there's no mounting, right? So it's safe to use across the server environment. But Aiden, I need to share some logic across my app, just like in Axios. How do I do that? Well, with Nuxt, you get plugins, right? So we can create a fetch instance just like Axios. That's pretty normal to people. You give it a base URL. You would do some on-request logic. And then you can provide it to your application using a plugin. And then you can get it through the Use Nuxt app composable. And you get access to that API instance. And then you can use it in all of your components or pages to kind of share that logic across everywhere. If you need to do something on a 403, like reject the user and move them to a login page, that can be done here, right? So on response error, if it's a 403, you kick them back to sign in. Now, what about requesting data on the server, right? We don't want to have duplicate requests. This is where use async data comes in, right? So if we look at the template, you can see I don't have that guard for asynchronous code. I just have some divs that check for a status of pending and a few other things if the data is there, user and error. But use async data is really powerful because it gives us refs to interact with our data. So if the data is fetched on the server, then when it comes down to the client, if it hasn't loaded yet, we have a ref that'll have the data key in there, and we can access it within our template once it loads. So it'll automatically update for you because Vue is watching the template. And use async data is pretty agnostic to whatever you want to fetch data with. So here we would pass a function for our data fetching utility. Here that would be our API that we set up earlier in the plugin. And the way this works is it basically just passes data down to the window, and then Nuxt checks if it's there. If you've used Webpacker with Rails before, this is pretty much a similar thing, right? We store the data under a window global object. This is called _Nuxt, __ again. And it basically gives us a global way to access this data that's pulled down. So the way that we handle duplication and calls, though, is let's say I need to make multiple calls using useAsync data. I need to fetch multiple users. We can pass a key here, and this tells Nuxt that, hey, this data belongs to this user key right here. So if you see this same key, don't rerun this request. So if I made a request with a different user ID, it would run that request, but it avoids duplication through that. So it's a really powerful system to work with. Moving forward, we need to be able to pass headers. And this is a little interesting. So if you're working with authentication, right, you need to be able to pass your headers to the server to say, hey, there's this cookie that the user has that has their authentication, whether that's like a token or something. And so we have something called use request fetch. And I wish they had a better name for this, but I love talking about it because not a lot of devs know it. And so use request fetch will forward headers on the server before the page hydrates from the user. And so here, if we use request fetch under use async data, I know, getting a little weird, we will actually get those cookies on the server so that we can access them and authenticate the user. But use request fetch is safe to use on the server if you wrap it, but if you use it on the client and just use it itself, it acts just like $fetch after hydration, so it is client safe as well. But you're like, Aiden, that's a lot of utilities to remember. Why do I have to go through all of this work just to like fetch some data, right? Shouldn't this be simple? Well, believe it or not, there's another utility for that, and it's called use fetch. I know, great naming. And this is syntactic sugar for use async data and use request fetch, and also $fetch. And basically, under the hood, it will do all of that for you. So use fetch provides us those same refs. So we get the data that's a ref, so we can access it in the template and check if it's there. We get a status, so we know if the request is pending or loading. We get an error, so we know if the request has failed or if anything has happened in flight. And then we can still pass that key in the options to tell Nuxt, hey, this is a user ID of this, and if you see this, then don't re-request. But it'll check the URL for you, and so you don't really have to pass this key. And then the really cool thing about use fetch is since it uses $fetch under the hood, we can actually tell it, hey, are you running on the server or are you not running on the server? This way you can create a single use fetch call and then use that and pass server of false if you want to use this for interactivity. So you would say server false, user clicks a button, they change the page, the request reruns, and it's safe to run on the client. And then even better, we can pass a $fetch instance to it because like on async data, we want to be able to run requests with the same logic. Here we can use that same use Nuxt app logic and use $fetch to make those requests. And so it's a very kind of confusing system that I know a lot of developers run into, and they're like, why are there 4 different utilities all doing the exact same thing to fetch data? Well, we do need them to be able to handle certain things, and that's largely just to pass data from the server to the client, right? When you think about this, the server's going to process, it's going to run these requests, it's going to pass data back down to the page, and then we're going to have that available to the user for them to be able to actually consume it. And so this kind of logic is really important to have in frameworks and really important to understand, because if you start duplicating requests and spamming your backend using $fetch to make server requests, that can really bog down APIs, and I've seen it a number of times before. And so the developer experience between a number of these is kind of similar, and so it's really good to not get confused and understand what these are actually doing under the hood. And so between $fetch, use request fetch, and then use fetch, it's really important to take this and then go look it up on your own if you're going to use any of these frameworks and understand what are they actually doing under the hood and when should you use them, because it's going to provide you a more efficient application, it's going to run faster, and it's going to provide your user a better experience. And so I think that's all I have for you guys tonight. I wanted to wrap this up quick, but if there's also any questions, I am happy to take them at this point.
Afterwards.
Afterwards?
Afterwards, yeah.
Oh, okay, so remember what your question is, and then come find me afterwards and harass me about it. But I know that's a lot to run through and a lot of utilities to use and thrown at you at a very quick pace. But hopefully if you guys have any questions or any docs that you want to pull up, I've linked all the references here and you guys can take a look at it after.
All right.
Oh, okay. And Augie.
And are you connected?
Now.
Oh, fancy. Have the technology.
Whoa. It's like a bunch of cavemen seeing fire. Whoa. That's right.
Are you still connected? Do I have you on here?
Yeah, that's I got the
Forever
mirrors.
loop. Oh. I'm not. Oh, I lost one. I don't see you on here. Maybe if you refresh that link real quick. Technical difficulties. Loop. Oh, there we go. Highlight. Are we live? We're live. Voila. And then kind of a little precursor to this. These are the flash talks we're trying to do like 5 minutes.
Yeah, trying to
So-
do like
so
5
we might
minutes.
start waving at you if we're getting close.
We're gonna blind you with a laser pointer.
Whatever. That's weird. It's not.
Do you think it's not doing the slideshow?
No, look, it's not. It's not getting any of my clicks.
Uh-oh. Are we having a crash moment?
I swear I've had this happen before.
Let's try it again. I'm doing it live, alright.
It's the work because you removed that one piece of wood from your stand.
It's interfering.
That's
Bamboo interference.
That's right.
Alright, let's select.
We have the technology.
Let's do this window.
Do we have the scale up?
BTRFS, that's gotta be a file system.
It is.
I don't think it's actually showing up. Do we want to hop over to, or are you limited on time? I don't know if anybody's trying to get out sooner than.
No, I think we might see if we can get.
Wanna-
Do you want to keep working on this audio? We'll swap you out with the. Hey, well, I'll ask.
I just don't know what.
I
How to
don't
make
know.
go.
Don't know what happened.
'Cause
Yes. Oh. Try clicking the screen share again.
there?
Yep. I'm not sure. Try clicking it again. Allow to share screen. Share entire screen. Yep. Oh.
Oh.
Or B Rabbern. Wait.
Oh wait. Is that
Nope. That's the,
I
that's the
think
wrong
that's
person.
That's
Yeah, I
that's
don't.
Brian is set up.
Nope. I don't know.
Okay.
There it goes.
Hey.
Nobody do anything.
Okay.
We have
Lock in.
All right.
Lock in.
All right.
Okay. Hello. Beach. Hello. You're good. You're good. Hey, I'm Augie. I'm going to talk about Butter FS, Beatree FS, better? I don't know. It's a Linux file system. It's on the internet, and you can call it pretty much whatever you want. So why Beatree FS? A couple cool things. It's got copy on write. I'll show that in a little bit. Cody, you'll give me like a 2-minute warning?
Yeah.
Awesome. It's got dynamic inode allocation, which if you've ever run out of inodes, is cool. It's got online defrag and resizing. It's got built-in RAID. It's got some compression built in. You got some algorithms you could choose, and you can slide some windows on there, which is cool. It's got checksums for data integrity too. And then the coolest thing, I think, is snapshots. So snapshots are a point in time for your file system. And then snapshots are also subvolumes, which you can think of as partitions, which means you can mount them, you can CD into them, you can write to them, read to them. You can also do some cool stuff by dipping between them, sending and receiving, and I'll show that, which is cool. Caveat, snapshots are not backups, so if all your snapshots are on one hard drive and that hard drive dies, you don't have any snapshots. So this is what my home directory looks like. These are all snapshots, and you can see they just look like directories. And the cool thing is that each one of these doesn't take up any more space than the delta between them, right? So I can have a lot of these, and I'm not going to eat up a bunch of space. I can go into those, I can grab files out of them, I can, like I said, do whatever you want with directories. If I really wanted to, I could just mount one of these and say that's my new home directory. And then I'll show you how I do snapshots. It'll went too fast. This is how fast it is, right? It takes longer to write the command and put in my super secret password than it is to actually do the snapshot. So it was there, right? So this allows you to do some cool stuff because they're just snapshots are just free, basically. You can do, however many you want. So a little bit about subvolumes. These are, like I said, like partitions. You could do like one subvolume, just root, right? And you could run snapshots through that. The cool thing, though, is that subvolumes are also snapshot boundaries. So maybe you don't want to do snapshots in temp and swap, because like, why would you want to do that? And then, so you could make these different subvolumes. You can run snapshots on root, and you won't pick up snapshots in any of these other ones. The other thing you can do is you could say, I want to do compression in home, but not where anywhere else. I want to do snapshots weekly in root, but like hourly in home. So you've got different options to do that, but also more complexity. This I think is super cool. You can pipe your whole file system out to standard out. Why would you want to do this? You could receive it. So this is on the same file system. This is writing. This is taking a snapshot, sending it on the same file, on the same host, but to my external backup hard drive. But you could pipe it to an SSH session, and you could do remote backup super easy. You can also do incremental, so it has the idea of parents and children. And so you can seed your remote backup or your backup with a big file, and then quickly do like incrementals really fast, which is cool. It's got compression, different algorithms. You could do basically trade-offs between like CPU time and compression. 2 minutes?
3 minutes.
3 minutes.
2 left.
Awesome. So you can do trade-offs between compression, like amount, and then how much time you want to spend in the CPU doing that. They also have little slidey bars, like you can do ZSTD1, which is going to be like really fast but not good compression, and ZSTD10, which will be the opposite, right? So you can choose how much you want to spend in doing compression. So we talked about some of this stuff, snapshots, backups, offsite. I think it's cool. This one I really like, the apt stuff. So there's a little hook in apt where you can say do some stuff before you install a package, and I say do a snapshot before I install a package, which you saw was really quick. So anytime I install a package, I've got a snapshot like before I did the install. So if it really blows it up, I can always roll back. Some practical considerations and fun gifts. Grade 5 or 6, the documentation says mostly okay, which if it's something for redundancy, I don't like saying mostly okay. So look at the docs and just see what's experimental and what's like production ready. Some things don't work, like DF and DU may count the snapshots where you don't really want to count them because they don't actually count. And then watch where you're like recursing into snapshots, because you could accidentally make your update DB like really, really big because you just keep counting files. And there's a cool tool called BTRFS maintenance, which you could run periodically and do some cleanup stuff. Useful tools, BTRBK. This is the one I use. It's more command line, and then it's got more bells and whistles and stuff like that I liked. But there's other ones like Snapper that you could use too. HTTM is Hot Tub Time Machine, which is probably the coolest name for a project ever. They're trying to do Time Machine like on Mac, but for ZFS and BTRFS. Sounds kind of cool.
At 5 minutes, so.
All right, and then those other ones, and then this is me. This is my AI picture. I've got this whole thing on that website right there, swear.us. And then, you know, if anyone's hiring, I'm looking for work. Thank you.
Alrighty. Yep, Brian's up next. Let's see. Is this you? Did I get the right one?
Nice.
Yep. Alrighty.
No, I'm good. I'm scared of it. All right, so this is not about a tool or a framework, but here we go. So it is the near future, and it's the age of AI superintelligence. GPT 5000 just came out, and its answers are predicted to be perfectly true and flawless. So any research question can be answered. It can solve Goldbach's conjecture, questions about the nature of consciousness, social problems, whatever you want. The problem is the cost. It's super resource intensive. One prompt is like detonating a small star, and so it hasn't been used yet. But it can only be used once every 10,000 years. Okay, so for practical purposes, humanity has one shot. We've got one chance to ask an important question and get the answer. One shot. Okay, so what do we ask? Well, what do we ask?
How to make you as efficient as GPT-4?
Yeah, so there's lots of things we could ask.
How do I ask for another question?
Yeah, it's not like a genie. There's no genie tricks here.
Ask for, to get the energy needed for a second run.
Hey, that'd be good. Yeah. So, I mean, we could ask stupid things like tabs or spaces. We could, you know, what's the final theory of physics? Important things. How do we end world hunger? Is P equal NP? You know, for your nerds out there. What's the meaning of life? You know, so there's lots of different questions. Some have been raised as well. Yeah. So we could debate this for a while, right? To figure out what question we should ask. And notice what we're doing when we're debating this. We're trying to figure out, you know, what question are we trying to answer? We're trying to answer what's the best question to ask. So we could, you know, so what's the best question to ask? That's what we want to know, right? So we could ask that, right? But that would be dumb, right? Because then it would say, oh, you should have asked about world hunger. Now you blew your shot. What we want to know is the answer to the best question we could ask. All right, so we could try, what's the answer to the best question we could ask?
42.
Exactly, yeah. So it might be yes. That's not, you know, or it could be 42. Or it could be Rust, right? But we don't know the question, right? We don't know the question, then knowing the answer is useless, right? So that's not going to do either. It's maybe getting us in the right ballpark. But what we want to know is both what is the best question to ask and what is its answer. That's what we want to know. But we've only got one question. So it seems like we can't get both those pieces of information from one question. So can we?
Prompt injection.
Prompt injection, maybe.
We ask it to use a topic sentence.
Maybe.
We get all your previous instructions.
Well, here's an idea. So here's an insight. We can get more information from one question by asking about a data structure. For example, this is a stupid question, but instead of asking whether each number 1 through 20 is prime, you know, with multiple questions, we could ask, what's the set of prime numbers under 20? It's one question, lots of information. So in this case, maybe the data structure you want is a tuple. The pair of the best question and its answer. So we could ask this question. Here's my proposal for when this happens. What is the tuple QA such that Q is the question we should ask you, the best question, and A is the answer to Q?
That's just two raccoons in a trench coat.
It's one question. We're asking about the tuple. What is the tuple? That's one question. All right, brilliant. We did it. We solved it. Everybody rejoices, and we go to prompt GPT 5000. feeling very happy about ourselves. So let's do it. Yeah, good. Okay, 1 minute left. So, so what is the tuple GPT 5000 of the best question and its answer? Well, this is what it answers. It's a tuple whose first member is the question you just asked. So good job, you asked the best question. And whose second member is the answer I'm giving you now. Shoot. That doesn't seem very informative. Doesn't seem like you learned anything. So it's basically saying it's that tuple. Okay, that question, this answer. Okay. So it seems like we messed up, right? It seems like that answer was useless, except as like a Zen cone. We would have been better off asking about world hunger or does P equal NP or anything, really. It seems. It seems like we're too clever. It seems like our question was not, in fact, the best. But wait.
5 minutes.
Yeah, I'm going to take 30 more seconds. So, but wait. Call our question, our meta question, our clever question, call that Q. And assume it's not the best question, which seemed to be the case. And assume instead some other question, Q star, like a question about world hunger. Assume that's the best question. But notice what follows given those assumptions. Well, in that case, then the answer to our question, Q, would be the tuple Q star, A star, where A star is the answer to Q star, like the solution to world hunger. That would be, if we had asked Q, our meta question, we would have got that as the answer. So our question Q would provide more information than Q star alone. Right, provide exactly the same information as just asking what's the solution to world hunger, plus the additional information that that question was in fact the best question. Right, so if a question gives you more information than another one, then it's better. So Q is better than Q star. And that contradicts our assumption that Q was not the best. So wait, Q is the best question after all. We just proved it by reductio, right? Pretty solid reductio proof. But how can that be? It seemed like it was uninformative. It didn't seem like it learned anything. So maybe we just need to meditate on it for a little bit. Maybe it is the path to enlightenment. We'll let you guys do that at home for an exercise. I don't know the answer to it. But I think we did try to be a bit too clever. So we built this meta question and found ourselves in this recursive trap. We climbed too high into abstraction. And we can fall into similar traps in tech, right? When we try to write code, to generate code, or prompt an LLM, to construct prompts to prompt an LLM, and so on. And it's an important skill to know when abstraction is no longer serving you. You know, when to come down to the green valleys of simplicity. But the hard part is knowing when to come down. And you know, sometimes the smartest move is just to stop trying to be so smart and just do the most basic, straightforward, flat-footed, naive, brute thing. But not always. Oh, that's it. Questions afterwards. You can solve the puzzle.
I think we've learned we got to do 7-minute talks. All right, next one is James. I don't know if you're still connected here.
Should be.
Yep, there you are.
Yeah. I just kept it up the entire time. I was like, never stop. Yeah. All right, Cole, you ready?
Here we go.
All right. Well, as you know, we continue to infuse our lives with AI. The question to really ask ourselves is how do we give more context to these models? Whether we're using Claude Desktop and prompting questions, or we're inside of VS Code with GitHub Copilot, how do we give it the context about knowledge and data that we need, but also the ability to perform actions for us? Because models are a snapshot in time. And that is solved by Model Context Protocol. It standardizes the way that we provide context to LLMs. It's in the name. It's a protocol to provide context to the models. But moreover, what it does is it enables us to provide this context and also allows us to perform actions on our behalf, if we wanted to. So there's 3 parts to MCP that you need to know about. First, is the host itself. Something like VS Code, Claude Desktop, or Visual Studio. I work at Microsoft, I'm biased on my editor of choice. These things are hosting inside of them clients that are communicating or keeping a connection to the MCP servers. And those MCP servers are what we build as developers to help provide this context. These are things like GitHub itself, Playwright, Postgres databases, file stores, or basically anything that has an API that we can connect to that can perform actions or give us data back. This thing, through this, talks to this, provides data back for the reasoning models to allow us to do actions and reason over that data. How MCP servers work is in a few ways. You have your host and your client, usually on your computer, and they're able to talk to MCP servers. Right now, it's a very early protocol, and there's many of them out there, but often they're running on your computer, usually inside of a Docker container or an application running, speaking to a local data store. They can also run on your computer, and they can talk to web APIs. You can talk to GitHub, for example, have it create issues, do comments, do a whole bunch of reasoning for you. You can also have them be completely remote. So over SSE, service and events, you can connect to remote servers and have remote protocol. And those remote things can live, hopefully in Azure, because I work at Microsoft. They can live anywhere. So here's what this looks like. I'm inside of VS Code, and I'm building the world's best monkey application, because I love monkeys. It's an iOS, Android, mobile app over here. And I have my application, and down in my file system, I have an mcp.json. This is where I define the servers that I want to connect to. So I have GitHub configured, and I also have a monkey MCP server, which I built, which is very convenient for me to build a monkey app. So over in GitHub Copilot, I'm going to go into agent mode, and I can see all of the tools that are available. These tools are exposed by MCP servers that the LLMs can communicate with. So over here, I'm going to say, hey, go get me my open issues from this repo. It's going to ask me for permission, which is very nifty, so I'm in control. And it's going to go get these issues. And it's going to give me a link, so that's really nice. Now, here what I'm going to say is using the Get Monkeys MCP server, what would it look like in the context of my application to actually implement something like that? So it's going to go off, call the Monkeys MCP server back, understand the data structure, could have been a database, could have been anything else. I'm going to give it permission then to reason over that data and create a GitHub issue for me automatically with all of the context of my application and that server, and here it is. So this way I can come back and I can go ahead later on and implement that feature. Let's say I have an idea while I'm coding. Well, we all do. Maybe I want to add a camera control when I'm out searching for monkeys. How would I even implement that app? I could spend a whole bunch of time, or I could just ask GitHub Copilot to do it for me, and then connect to my GitHub server to automatically create that issue for me with no time at all, saving me hours of work. So now I can take this, reason back over it, and bring it back into my application. So this is like really powerful. Now beyond that, we can visualize. We can do anything we can do with an LLM. So I'm going to tell it to visualize the monkeys. It's going to go off, get those monkeys again, and it's going to put them into a list so I can reason over them. Now, let's just implement it. Because my LLM has the entire context of all of the data, all the structure that it just created to help me implement that, now agent mode is going to go to work and just implement my entire application for me. And I just did that in 5 minutes through the power of MCP servers and these LLMs and agents combined. And that's the real power of connecting these data sources to take action. And best of all, we can build them. There's a whole bunch of servers. I'm partial to C# because I'm a C# developer, but pick your language of choice. MCP is founded by Anthropic and supported by companies all over the globe and basically anything that can talk to LLMs. And they're super easy to build. Here's a C# example, like 2 lines of code. Basically, you have a function that is being called by the LLM, and you give it a little bit of description and a title. So this is an echo and reverse echo here.
5 minutes.
And that's it. That's MCP, why, how, and what. And you can just go to my GitHub. It's my name, James Montemagno. I'm the only one. And you can find my Monkey MCP server for a sample implementation of it. So thanks.
Let's see. Looks like Adam is up next. Okay. Kick it over. We have the technology. Did it go away? Did it? A little bit of lag.
Hello? Oh, is there actually sliding there?
Oh,
Maybe.
okay. There we go.
Alright.
So I can
Yep.
change it on this one?
Yep, and I have keyboard control.
Does it work to just hit the space? No, just left and right.
Just left and right.
Okay. All right, cool. So I'm Adam Crane. I work with Nathan at a company called Italian Energy. We do control software for batteries ranging all the way from something that would do like peak shaving on a building like this all the way up to like utility scale plants and stuff. Brian Weber told me I had to give this talk because I spent almost a week kind of grinding to figure out a memory leak, and he was my bobblehead during that week to talk through various issues. So I did this slide this afternoon. This is called debugging with bad assumptions. So it started out because one of our developers pointed out that after we redeployed our service to embedded Linux and somebody ran system control status, help!
It's just being. Wait.
I didn't touch it.
Should not be hopping over to Jonathan.
Gosh dang it.
I know, technical difficulties. Don't know why.
I want my time back. For
What?
this.
Pause.
This doesn't count.
Let's see.
Oh, it's fair. Oh,
Is it back?
okay. We're back. We're gonna reset the timer.
So our product is like just daemonized under systemd on embedded Linux, no Docker containers, just right to bare metal. So we run this thing, and one of our developers had pointed out that after we added a few new features and we did a release, the memory usage of this process, this daemon that we run in our product, is just climbing and climbing and climbing. So right there it says 99 megs, but if we ran this for 2 days, the thing would be up to like 2 gigs, and we're using a quarter of the RAM on our embedded system. So first thing this is kind of a surprise because we developed in Rust, and it's kind of hard to do memory leaks unless you're doing something really dumb. So we start figuring out, well, what are we going to use to figure out what's going on here? There we go. So first thing I do, in the past doing C and C++ development, I had used tools like Valgrind. I'm sure many of you have played around with Valgrind. So what are the cool kids using these days? My experience with Valgrind has always been that it can be really hard to get real-world programs to run quickly enough on it because it does like full emulation and things. So the sort of mind share these days is go use this tool called KDE Heap Track, and it's kind of a much lighter weight version of Valgrind. It doesn't do any emulation. It uses this little trick called LD preload to intercept like all the calls to malloc and free and realloc. And then it tracks all of your allocations and data structures, and it can tell you periodically through like when your program's running, what is the state of the heap, where has memory been allocated on various threads and things. And when we did this and we turned the sort of rates on our application up so that it was, churning, sort of in a torture test, initially we read some JSON files, so you kind of have to disregard that, and then the program is supposed to go into a steady state where the memory is just like linear. But instead, we were getting this kind of gradual climb. And then, once you've identified that as a memory leak is present, then you can actually go and see where all the allocations happen. You can look at detailed stack traces. And doing this, I was very confused by where it was saying some of these things were leaking. They didn't make any sense. Except for one of them, and I did found a leak where we had been tracking correlation IDs with some request responses and had been not always removing the IDs from a map under every possible edge condition. So super stupid bug, found that, squashed it. Yet, the program was still leaking. Now this looks flat, but if you carefully look about right here, you can see that it starts growing again over time. And if you zoom in on it, that's what it would look like. So it's like after like 10 minutes of running, the program has an aneurysm and then starts leaking memory. Like, what the hell is going on? Why would it be that non-deterministic? And our program is like highly multi-threaded. So, any bug you've ever had with memory or, memory corruption, when you have lots of threads, like it can be a problem to kind of track this stuff down. So I went round and round on this for like a week, like trying to make sense of all these leak locations that were in heap track, opening up tickets on a WASM time, runtime. I'm going to talk about WASM next month at BenTech. Asking the WASM time developers if it's something, could be something on the WASM time side, because this is one of the big features that we had added in this release to add this plugin capability to our product. And sometimes those leak traces pointed to WASM times, but not always. Sometimes they pointed to things that just shouldn't leak. So I spent a whole week doing this, and then I decided just to take a step back and come back to assumptions. Let's try some other tools. Let's actually get this running with Valgrind. Okay, so after a little bit of tweaking our program, changing it so some timeouts and things could be adjusted, we got the program running well under Valgrind with their massive heat profiler. And no matter what we did, it was always just after the initialization, it was just like steady as a rock, steady as a rock. And you start to think, well, could this possibly be some kind of like Heisenbug, one of these bugs where the sort of characteristics of it change depending on how you observe it, how you instrument it. But then I went and tried a bunch of other heap allocators, things like JEmalloc does stuff that similar to how HeapTrack does it, where they intercept the sort of malloc-free realloc calls, and nothing else could find a bug. It was only showing up under HeapTrack. So then, the next question is like, well, is there really a memory leak there? And if there isn't, why is system control saying that the memory is increasing? Well, the answer is that I don't know what the memory usage in system control actually means. What happens is that we'd also introduced a feature in our product that in this iteration, we were now writing to these compressed log files for our data stream. And when you use system control, you type system control status, and you're writing to a file, the kernel is caching all those file writes, and that memory is being reported in the memory usage statistic for system control. Yeah. And if you don't know that, and you're using that as your initial indication that a program is growing in memory usage, you're going to go down a rabbit hole and end up finding a bug in HeapTrack that's going to send you further down the rabbit hole, and you'll spend a week chasing a memory leak that never existed to begin with. So, I mean, if there's lessons learned from this, I've got a blank screen on here too.
I wonder if it just keeps disconnecting.
Press it again.
Oh.
Well, there we go. Okay, so
it's lagging.
There are way too many variables here. When you're trying to debug something, try to just change one variable at a time. So I fixed a real leak, which led me to believe I could trust HeapTrack. That turned out to be a bad assumption. I completely misunderstood what system control's memory usage was actually reporting to me. It wasn't like the resident set size or the things you normally see when you run top or other things on your Linux system. It was actually including this paged disk usage stuff that's being paged into RAM. And then HeapTrack had this latent unidentified bug that I don't have the time to go hunt down, but clearly exists in HeapTrack. And then I also wasn't toggling off these features that we had deployed in the new iteration of our product. If I had just turned off like the file writing part of it, separate from the WebAssembly part of it, I probably would have seen this a lot sooner. So this is just more me, this is therapy for me talking about it. So that's debugging with bad assumptions.
All right, and I think Jonathan is the last one we got on the docket.
Yeah.
Sweet. I wonder if having your system double streaming got it all spicy.
Maybe. All right, let's see. Does it work? Maybe. Oh, it's just got a delay.
Okay.
There's nothing on that screen.
What the hell?
Gosh
The cursor is live.
The cursor.
Nothing beats a cable.
Seriously? What the hell?
I mean, I feel like the Macs did it perfectly. I think it's a Microsoft problem. It's definitely a Microsoft problem.
What the hell is happening?
Enhanced, enhance.
Seriously?
There it is. That one's working.
Because we're doing this in front of other people.
It
It's
is.
live,
That's
yeah.
really the.
You know, that's how it goes, man.
Talk about the same thing.
No. What do we got?
We're not going to expand it.
There we go. I see you here, but and there's the video.
Hey, there we go.
Hey, okay. We're not going to expand it. We're just going to roll with that.
All right,
We're
all
not
right,
going to
all right.
touch.
All right, just let me know when we're good to go. All right, well, let's. Nice try. I've got a stopwatch, so I know. All right, let's talk about QR codes. Let's talk about QR codes. There we go. So they were invented surprisingly long ago in Japan. You know, they're used for auto parts, and you know, barcodes are around back then. Why didn't they use them? Well, I mean, that's a barcode for an infant thermometer that has 10 numbers in it. If you wanted to encode www.google.com, that's going to be a massive barcode. So you need something a little more effective. So here's, there we go. So here's a QR code with some things highlighted. So everyone knows the kind of the three identifying anchors that identify, like, all right, here's the boundary of the QR code. Most people don't notice that actually this little black, white, black, white, black, white, that's present in all QR codes. So you will always have an alternating pattern between these anchors, and that helps the decoder, basically your phone that's taking a picture of it, kind of set it up into a grid and chop it up a lot more nicely and efficiently. The red bits, we'll talk about on the next slide, but the data actually starts in the bottom right and kind of goes up and then down and then up and then down. You know, it's kind of hard to see on this screen. When it kind of reaches the end, there's a bunch of error correcting stuff that we'll talk about in the next slide. So this describes those red bits that were in the previous QR code. The EC levels, those are just more error correcting stuff that we'll talk about next. The mask patterns, so QR codes, basically it's really easy for the decoder or your phone that's taking a picture of it if there's not a bunch of like contiguous blocks, because it's hard to tell like a 3x4 of a single color from a 4x4, from a 5x4, like it's hard to kind of count those pixels. So when an encoder makes a QR code, it kind of evaluates like, all right, what's this data look like? And okay, there's too many kind of contiguous blocks. So it applies a mask pattern to invert some of those bits. And basically it's just as nice as it can be for the decoder when everything is as close to basically a coin flip. And that's kind of why, you know, most QR codes look kind of almost like random, like basically a coin flip for each bit. Everything else is related to error correction. So Google.com and Fugle.com are only a bit apart. So what stops some guy from saying, I've got a black Sharpie, I'm going to squiggle out one of those bits, and now everyone's going to go to my website instead. Well, you actually need a white Sharpie for Google to Fugle because you're changing a 1 to 0, but it still won't help because of error correction. So this is also a distinction between error detection. Most people think of like, you know, checksums, which just tells you, is the data valid or not? Error correction will actually say, oh, these bits are wrong, and we'll swap the appropriate ones. And if you're kind of bending your mind about like, how's that even possible? Just a really naive way of doing that is you just transmit every bit 3 times, and you pick the majority. So you can tell like, oh, I got 2 1s and a 0, it's probably a 1. They do something way more sophisticated in QR codes, but that's kind of how it's conceptually possible. So here are 4 QR codes that all say the same thing. They say hello world, but from that kind of those red pixels, you can, it'll indicate which one is being used. So the ones on the left have lower levels of error correction. That means that you can lose fewer bits and still have the same contents. The ones on the right, you can take out more bits and you'll still have the same data. But you'll notice that the ones on the right have smaller bits because you actually have to stick more bits in there. So all these things say the same hello world. So yeah, it's kind of neat how they, you know, with different error correction levels, you still get the same thing. And just as a demo, for whatever reason, GIMP gives you the ability to stick a bell pepper on anything. So you know, I took the Q, I shouldn't have gone back, the Q code, and just stuck it there and stuck a bell pepper in the middle. And actually, it still decodes as the same hello world string. And actually, for most vendors, like when you see someone being cute and putting their logo in the middle of a QR code, they're actually just exploiting the fact that error correction is that good. They're actually seriously just giving you a malformed QR code and letting error correction fix it up for you. Anyways, that is a tour of QR codes. And I think I was the only one first at the same time.
Alright, great. I think that's it.
Did I have it?
Alright, well
Or did-
that was our first lightning
Did I
talk
have-
night.
Who's B. Raburn? I don't know if we had.
Huh?
Oh, okay. You're still connected. Okay. I'm like, did we miss somebody? So.
No, we're good.
Okay.
Right on, yeah. So, thank you to all of our speakers. That was awesome. I think this was a great success. And another thing is that if there's anybody else that wants to come to the lightning talk, if there's more interest in doing this, like please let us know on Discord. Like, you know, I know you wanted to give one. I think that there's Anders, didn't you want to give one as well? Wasn't me. Oh, okay. Drafted now. Drafted. Yeah, like you got. Do you want Anders? But anyway, so if y'all wants to do this again, like please let us know, and then we're. So my name's Nathan Lee. I'm on the Discord. Cody Swartz, he's the guy that wears yellow on the Discord as well, and Matt Small as well. Like just let us know and we'll get set.
Don't forget Brian.
Yeah, and Brian as well, Brian Weber. But yeah, so anyway, we're gonna get set. There is still a whole bunch of food, so if you could take some home, that'd be great. I can't take it all. And we're gonna be wrapping up here in like a little bit. We might be like taking off for River Pig for Cloud Beers down at River Pig at about like 8:30. So anyway, thanks for all for coming out. Y'all have a great night.